Alright, these are more exercises solving logarithmic equations from 9.6. Alright, so remember these properties. Log A of m times n equals log A of m plus log A of n. Also, if I got log A of m plus log A of n, I can rewrite that as a single log. Log A of m divided by n equals log A of m minus log A of n. Also, I can write this difference, log A of m minus log A of n, as the quotient. Now, two more properties we got to remember. Log A of A equals 1, and it don't matter what this base and this result are, if they match, it's going to equal 1. In the same principle, the ln of E is going to equal 1. So I'm going to start these exercises at number 10, and we're going to solve for x. So I got log base 6 of x equals 1. So I'm going to rewrite this as exponential. My base is 6. The exponent is 1, and that's going to equal the result, which is x. But 6 to the first is 6, so my final answer is x equals 6. Number 11, I got log of x equals negative 2. So remember, since there's no number shown, it's understood to be a 10. So this is 10 to the negative 2 equals x. Now, just remember, 10 to the negative 2 is the same thing as a 0.01. Notice I'm 2 decimal places left when it's negative. And that's going to equal my x. So not much work on them two. Number 12, I got log base 6 of 2x minus 2 equals 3. Alright, so my base is 6, exponent is 3, and that's going to equal 2x minus 2. So let me hit the calculator real quick. 6 to the third power is going to give me 216 equals 2x minus 2. Solving this for x, I'm going to add 2 to both sides. So I get 218 equals 2x, and then divide both sides by that 2. So I get my x over here, and then 218 divided by 2 is going to give me 109, final answer. Right, let's see, 13. I got a log of x plus a log x minus 3 equals 1. And so since the logs are on the same side and being added, I'm going to write them as a single log. And I'm going to use my product rule up here, which says that the log of a sum is the log of that product. And all that's going to equal 1. So remember, the base is 10. The exponent is 1. And what I'm going to do here is just distribute that x and multiply that out so that I get an x squared minus 3x. Alright, 10 to the first is 10. So to solve this, I'm going to subtract 10 from both sides. I get 0 equals x squared minus 3x minus 10. Now at this point you could use the quad. A would be 1, B would be negative 3, C would be negative 10. But what I'm going to do is factor that. I know there's an x and an x. That's negative, so I got a plus and a minus. Factors of 10 that equal 3 are 5 and 2. Since the 5 is the larger number, it'll be negative like the middle, and the 2 will be positive. And then remember, set both them equal to 0 and solve for x. So on the first one I subtract 2, I get x equals a negative 2. Second one I add 5, and I get x equals a positive 5. Now if you check these answers and you put a negative 2 in for that log, when you take the log of negative 2, look what happens. Log negative 2, hit enter. It's a non-real result, so I cannot take the negative answer, and the only answer will be x equals negative 5. So let's see, number 14. I got what? Log base 2 of b plus 36 minus log base 2 of b plus 6 equals log 2 of b. So y'all, the first thing I'm going to do is move this log to the other side so all the logs are on the same side. So I'm going to subtract a log 2 of b from both sides. Now remember, none of these are like terms, so that's going to end up in log 2 of b plus 36 minus a log 2 of b plus 6 minus a log 2 of b, all equal to 0 now. Alright, so let's write this as a single log now. Now, over here I'm going to put my log base 2. On top I got the b plus 36. All these that are being subtracted are going to go to the bottom, so I get a b plus 6 and then that other b down there. All that's equal to 0. I think the only other thing I'll do at this moment is distribute that b, so I get log 2 of b plus 36 over b squared plus 6b, all equal to 0. Alright, so now we're going to rewrite this. Since we got a single log, we're going to rewrite it as exponential. So I got a base 2 to the 0 power equals b plus 36 over b squared plus 6b. Alright, 2 to the 0 is 1. So I get 1 equals 1 plus b plus 36 over b squared plus 6b. Alright, so the thing here to do, since that b squared plus 6b is on the bottom of the fraction, we're going to multiply both sides by b squared plus 6b to get rid of that fraction. So on the left side, b squared plus 6b times 1 is just b squared plus 6b. On the right side, the b squared plus 6b's cancel, and all that's left is a b plus 36. So to finish solving this, we need everything on the left side and equal to 0, so I'm going to subtract the b first. So b squared plus 5b equals 36, and then we'll subtract 36 from both sides. Once again, no like terms over here, so you get b squared plus 5b minus 36 equal to 0. At this point, you could use the quad, 1, 5, and negative 36. I'm going to factor it. Since it will factor, I got a b and a b. That's negative, so you got a plus and a minus. Factors of 36 that equal 5 are 9 and 4. Since the 9's bigger, it's positive like the middle. 4 will be negative. Then set both them factors equal to 0 and solve. So the first one we subtract 9, we get b equals a negative 9. Second one we add 4 and we get b equals a positive 4. But once again, if I put that negative 9 up here and try to take a log 2 of a negative 9, I get a does not exist type answer. So the answer is only going to be b equals 4. Alright, 15. Log base 4 of x plus 1 minus log base 4 of x equals 2. Alright, so since the logs are on the same side, I'm going to rewrite them as a quotient. So I got log base 4, x plus 1 will be on the top. And then since that's being subtracted, the x will be on the bottom, all equal to 2. Now we'll rewrite it as exponential since we got a single log. So I got 4 to the second power is going to equal x plus 1 over x. Alright, so let's 4 squared. That equals 16. So 16 equals x plus 1 over x. Once again, I'm going to put a 1 under the 16. The LCD of this is the x, so we'll multiply both sides by x. Over here, x times 16 is 16x. Over here, the x's cancel, and all that's left is x plus 1. So to solve that, I'm going to get the x's on one side. So I now have 15x equals 1, and then divide by 15, so that I get x equals 1 over 15, final answer. Alright, let's see. Let's get 16 right in here. Alright, so 16 is log base 4 of x plus log base 4 of x plus 1 equals log base 4 of 6. So, same thing, y'all. I need all the logs on one side, so I'm going to subtract a log base 4 of 6 from both sides. So, let's see what that does. That's going to give me log base 4 of x plus log base 4 of x plus 1 minus log base 4 of 6 equals 0. So, let's write this as a single log since all the logs are over here. So, we got log base 4. Since these are being added, they'll both be on top. X times x plus 1. The one that's being subtracted will be on the bottom. So put your 6 on the bottom. All equal to 0. Alright, so the only other thing I might do is distribute that top real quick. So I get a log base 4 x squared plus x over 6 equals 0. So now let's rewrite this as exponential since we got a single log. So 4 to the 0 power equals x squared plus x over 6. Alright, 4 to the 0 is 1. So you get 1 equals x squared plus x over 6. Treat that like a fraction. This time the LCD would be 6. So I'm going to multiply both sides by 6. Over here, 6 times 1 is 6. Right side, the 6 is canceled. So you're left with x squared plus x. Since it's quadratic, subtract 6 from both sides. So that 0 equals x squared plus x minus 6. And then I'm going to factor that, but remember, you could use the quad. Alright, that's negative, so I got a plus and a minus. Factors of 6 that equal 1 are 3 and 2. Since the 3 is bigger, it'll be positive like the middle. The 2 will be negative. And then set both them equal to 0 and solve for that x. So here we subtract 3. Here we add 2. But once again, remember I can't take the log of a negative number because it does not exist. So the only answer would be x equals 2. Alright, so I'm going to bring 17 in here so I can finish that on this page. I got log 6 x plus 8 plus log 6 x minus 8 equals 2. So my logs are on the same side and being added. So we're going to write that as a product x plus 8 times x minus 8 all equal to 2. And I think I'm going to actually FOIL that out real quick. So if you FOIL the x plus 8, x minus 8, you get an x squared minus 8x plus 8x minus 64. The middles cancel, so you end up with an x squared minus 64. And all that's equal to 2. So now I'm going to rewrite this as a single log. 6 to the second power equals x squared minus 64. Alright, 6 squared is 36 equals x squared minus 64. So at this point, I'm going to add 64 both sides and take a square root. So I get 100 equals x squared, taking square roots of both sides. Remember, that's going to be a plus or minus 10 equal to my x. So we got x equals 10, x equals negative 10. Remember, if you put that negative 10 in there, that's going to make that negative 10 plus 8, which is a negative 2. You can't take a log of a negative number, so we can't take that answer, and the only answer would be x equals 10. Alright, so let's see. That looks like all of them. So just remember, when you got logs being added, write them as a single log being multiplied. And when you have them being subtracted, write it as a single log being divided. Good luck, and we'll see y'all later.